Okay, so let us go with conduction through walls. So ang prelim natin will be comprised of conduction lang naman hanggang pipes. Okay? Discussions and then yung problem sets nila after ng discussions. Now, conduction through walls. 'Di ba ang mga bahay natin, kung mapapansin nyo, mainit sa labas, tumatagos hanggang loob, 'di ba? Ganun yung heat transfer. Okay? Kaya tayo naglalagay ng air conditioning sa ating bahay kasi kahit sarado mong pinto, ang init ay magpapasok at papasok pa rin sa lahat ng crevices. Okay? There's no body, okay, na hindi pwedeng magkaroon ka ng heat transfer. Na-negate niya yung heat transfer. Okay? Ibig ko sabihin, merong minimal effect yung mga insulations. Pero not all the time na yung body na yun, it will not make the heat transfer from one side to other. Now, conduction through plane wall. According to Fourier's law of heat conduction, the rate of heat flow through a simple homogeneous solid is directly proportional to the area measured normal to the direction of the flow and the temperature gradient in the direction of the heat of the flow. Ang dali, no? Now, for steady state and unidirectional flow of heat, unidirectional ibig sabihin isang way lang. The flow of heat through a homogeneous plane wall, the Fourier equations gives the heat by the conduction. Ito yun. So, nag-dt over dx. Yan ang mga pinakaayaw natin, di ba? Calculus. Di ba? Ayaw natin yan. So, fast forward. Dinerive niya yung Fourier's law of conduction. Now, when you have a wall here, okay, and this wall, from this side, which is hot, and this one, this is cold, you have to consider, okay, the thickness of that wall na dadaanan ng heat mo. Ibig sabihin, magkakaroon ka ng heat gradient. Anong ibig sabihin nun? That your heat will dissipate throughout the thickness of this wall. Napabawasan. So, from the hot side to the cold side, the heat transfer is also affected by the resistance of that certain material to heat. Anong tinatawag mo doon na resistance? That is the thermal conductivity of the material. Ayan, no? And it is oftenly measured in watt per meter degree Celsius or watt per meter degree Kelvin. Note that a substance with a large value of K is a good heat conductor. Okay? One with a small value of K is a poor conductor and a good insulator. Ibig sabihin, good conductor. Magandang heat transfer material. Okay? Pag mataas ang kanyang K or thermal conductivity. But if K is very low, mas magandang insulation na lang siya. Okay? Kino-consider mo yan. And every material, iba-iba yan ang thermal conductivity. Okay? Merong material dyan na kahit anong gawin mo, hindi siya magko-conduct ng heat kasi napakababa ng kanyang thermal conductivity. Okay? And, pagtatandaan nyo, sa conduction, Q. Pag nakakita ka ng Q, nakahanap ka ng ka-text. O, diba? Pag nakakita ng Q, nakakita ka ng ka-text. O, yan yung palatandaan natin. Pag nakakita ka ng Q, nakahanap ka ng ka-text. Okay? Ka-text. Ayan o. Diba? Yun lang po yun. Where K is the thermal conductivity, R is the area of the wall. Kasi extended yan eh. Okay? Extended yung wall na yan. May area yan. Okay? That is the area kung saan magpo-flow yung heat mo. And TH minus TL is the temperature difference from the hot side to the cold side, all divided all by the thickness of the wall. Kasi kung consider mo yung thickness, bakit? Yun, dun siya magpa-pass through eh. Yun yung lalabanan or dadaanan ng heat mo. Okay? That is the conduction through plane wall. How about, syempre, di ba? Kuwari, ang bahay mo, di ba? Manila City Jail, di ba? Yun, magandang example. Yung walling nila, hindi lang iisa. Di ba? Hindi lang pader yan. Meron pang insulation, meron pang pader ulit. Di ba? Hindi ka pwede pader lang yan, nag-iisa lang. Commonly, sa mga bahay, dun sa mga winter type na lugar, winter continents, ang bahay nila, hindi lang yan purely brick. Meron din silang may nakalagay na plaster. Meron din silang nakalagay na wool para magkaroon ng heat insulation. Hindi makawala yung heat dun sa kanilang bahay. At gumanda yung kanilang heat flow sa loob ng bahay. Okay? Hindi lumamig kaagad yung kanilang bahay. Tignan niyo yung mga ref nyo. 'Di ba? Aside from metal, yung palaman ng metal na yon sa gitna ay urethane or polyurethane foam. Kung saan yung polyurethane foam is a very good insulator that traps yung or it does not allow heat transfer from the hot side to the cold side. Kung saan yung cold side mo is yung nandoon sa loob ng ref. Okay? Kaya ginamit nila yung polyurethane. Ano ba yung polyurethane? Yan yung kulay dilaw na foam. Okay? Now, let us go dun sa multiple walls or conduction through composite walls. For a composite wall shown in the figure, di ba? Kuwari, itong wall na to made out of cement. Ito, made out of wood. Ito, made out of concrete. Oh. Ibig sabihin, iba-iba yung magiging heat transfer sa kanila. Okay? Iba-iba. Iba-iba pero constant ang heat for steady state. Ba sinabing iba-iba? Actually, mali ako dun eh. Dapat, ang heat transfer sa kanila, na may measure lang yan, pare-pareho lang ng heat transfer. Ang nagkakaiba lang dyan is the overall resistance. Kasi magkakaibang material ang nandyan. Okay? And kung mapapansin mo, that the flow is parallel. Kaya nagkaroon tayo ng parallel resistance. Sir, ano ba yung parallel resistance na yan? The overall or total resistance is the sum of all the thicknesses divided by the individual thermal conductivities of the material that is present on the wall. So, we put this into equation. Di man sabi ko pag conduction through wall, catex. Catex. But, ang problema dyan, magkakaiba to. So now, the resistance is, simply we put it this way. Okay? This is the overall total resistance. Or, yung conduction through composite wall is equal to the area multiplied to the temperature difference from hot side to cold side divided by RT, where RT is the overall resistance or the sum nung ratio between the thickness of the wall and the thermal conductivity. Okay? Where at steady state heat transfer, the total Q is equal to, since they are parallel, parang piping. Pag parallel, Q is equal. So, Q1 is equal to Q2 equal to Q3. What's the only difference? The only difference is that yung K mo iba sa bawat isa and then yung thickness is iba sa bawat isa. And syempre, equal man sila ng magnitude in terms of heat, magkakaiba pa rin yung transference ng temperature. Okay? And that is the conduction through a composite wall. Better way, naipakita natin yung solving na yan, naipakita natin yung notion kapag nag-solve na tayo ng values. Okay? Ito yung summary. And you will get the entire notes after the discussion. So you have here a couple of sample problems. Okay? So you might as well try this. Okay? Try niyo itong sample 1. This will be your activity. And sample 2, yung activity ulit. Okay, let us go with conduction from fluid to fluid. Problema dito, hindi lang naman yung conduction mo is from wall to wall. Kailangan mo din i-consider yung ambient air dito and then the air inside or outside. So, considering them, okay, with the conduction through plane wall, iko-consider mo rin, siyempre, yung surface film conduction on the hot side and then surface film conductance on the cold side. So, yung RT mo, itong RT na to or the total or overall resistance, idadagdag mo ito. Okay? Pakikita ko po sa inyo yung best way para isolve mo siya step by step. Kasi ito, pag nag-input ka na nito, napakahaba na nung equation. Okay? Ayan yun. So, na-finalize siya. With fluid to fluid. And same pa rin naman, equal yan. But, yung Q mo is equal to, kapag ito, kinonsider mo yung labas ha, tsaka yung loob. Ito, itong side na to, and then yung side na to. Yung Q there is equal to, may iba lang equation. Ito yung sa walls, ito yung sa film. Ito yung sa film. So, HI, A, T1, TI, T1, ito rin yung sa outside. Makikita nyo mamaya pag sinolve ko yan. Ito yung sample problem. You might as well check it. But recorded na to, recorded na siya. So, what better way for us to understand it is to solve the entire problem. To solve ko siya, okay? So, let's go to the problem sets. I have here actually 5 problems involving yung heat transfer of conduction. Okay, so let us solve this. So, for problem number 1, if 1,080 joules of heat is transferred through the window in every second, how much energy will be transferred in a year? How much energy? Di ba ang energy is measured in joules? Ang binigay sa'yo dyan is power. Tama? Ayan o, the power is heat power. So that is 1,080 joule every second. Ang hinahanap natin is the energy. Di ba ang energy, di ba ang power is equal to energy over time? Okay. So, energy is equal to power times time. Now, ang hinahanap natin dito is the energy transferred in a year. Okay. Very basic. So, energy is equal to yung power na ibinigay sa'yo, 1,080 over joule over second. Ngayon, ah nakalimutan ko yung diretso. Mamaya maalala ko rin yun. So, daanin natin doon sa mahabang proseso. Okay? So, you have 60 seconds in every, or 3,600 seconds, 3,600 seconds per day. Ito na yung pinakamabilis. Tapos, you have 360 days per year. Kapag ordinary, pero pag exact, ginagawa natin 365 yan. Tignan natin kung ilan yun. 8,760 ata yun? Try ko 365 times 60. Huh? Seconds. Sa hours. Okay. 24. 365 times 24. Yan, 8,760. Tama nga. There are, in 1 year, in 1 year, there are 8,760 hours. Okay? As in 1 year, you have 365 days. Normal to. Yung conversion na yan. Now, ang hinahanap natin in 1 year. Okay? So, multiply natin yung time. O di 1 year. Cancel yung seconds. Cancel yung seconds. Yung day. Yung day. Yung year. Yung year. So, you have how many joules? 1,080 times 3,600 times 365. Yan na yung pinakamabilis. Okay? The answer is, ang laki, no, nung energy is equal to 141912 1, 2, 3, 4, 5. 4 lang pala. So, that is 1,419,120,000 joules. Yan yung energy transferred in a year. So, that is for problem number 1. Very basic lang yan. How about problem number 2? Calculate the energy transfer across a 6-inch wall of fire brick with a temperature difference across the wall of 55 degrees Celsius. The thermal conductivity of the fire brick is 0.65 BTU per hour degree Fahrenheit. Sir, meron ba tayong conversion unit dito? Yes, we have a conversion unit there. Lo and behold, sasama ko na yung pinakamabilis na paraan para makalculate mo siya. Alam ko meron yung diretso eh. Hanapin ko lang kung saan nilagay dito. Well, anyway, sige. Proceed tayo para hindi tumagal. Ang given niya, meron kang K, 0.65 BTU per hour, feet, degree Fahrenheit. And then, given yung kanyang X, which is 6 inches. And then, yung temperature difference, which is 55 degrees Celsius. Now, ang kinakalculate natin dyan is yung Q over A. Yan ang tinatanong. So, better for us to draw it first. Drawing muna natin yung wall. You have the wall here, okay? Yung wall mo. Now, magpapass through daw dyan yung heat. Tapos yung X mo dyan is 6 inches. Okay? Ayan. So, this is brick. And then yung delta T is equal to 55 degrees Celsius. Now, di ba sabi ko pag conduction, Q is equal to ka-text. Ka-text. Yan. Now, binigay na sa atin to. Ayun o. Temperature difference. Ang inaanap na lang natin dyan is Q over A. That will be equal to K delta T over X. Now, let us solve. Q over A is equal to, yung K dyan, 0.65 BTU per hour feet degree Fahrenheit. Tapos yung delta T, that is 55 degree Celsius. Naalala nyo ba na kapag change in temperature, okay, Fahrenheit to degree, Celsius degree, pag nauna yung degree, okay, that is hindi siya change in temperature. Temperature lang talaga siya. Pero pag nahuli yung degree, that is change in temperature. Now, from degree Fahrenheit to degree Celsius, ang change niyan is all you have to do para maging Celsius siya, yung degree Fahrenheit mo, divide mo ng 1.8. Okay? Para maging Celsius degree. Now, how about naman yung degree Celsius to degree Fahrenheit? O simple lang, ang gagawin mo dito is i-multiply mo ng 1.8 yung degree Celsius para maging Fahrenheit degrees. Ito yung kanilang conversion. Or simply, Yung isa, multiply mo ng 5/9, yung isa, i-divide mo ng 9/5. Okay. So, let us proceed. Yung x is 6 inches. Tignan mo muna, anong hinihingi sa'yo na unit? Ang hinihingi sa'yong unit is watt per meter squared, naka-SI. Ilan ang naka-ano sa'yo dyan? Ilan ang naka-English? 1, 2, 3, 4. Lahat sila naka-English, di ba? So, I want it to become in SI. So, all you have to do is QA, Q over A is equal to 0.65 BTU per hour, feet, degree Fahrenheit. Okay. Ito, i-multiply ko ng 9/5 or 1.8. 1.8 multiplied to 55, magiging Fahrenheit degrees yan. Okay. And then, yung 6 inches ko, okay, 6 inches, i-multiply ko ng 1 feet per 12 inch. Tignan natin kung may nakakancel. Okay? May kulang pa dyan. Cancel muna natin yung mga dapat natin i-cancel. So, yung Fahrenheit degree, yung feet, yung feet, yung inch, yung inch. Yung hour, ang problema mo dyan. Okay? Madali lang naman yan. So, all you have to do is, hindi ko kinancel yung feet actually magiging feet squared yan. So, ang lalabas na unit dyan is 0.65 BTU 0.65, maya mo na i-multiply, times 1.8 times 55 per 0.5. Kasi 6/12 is 0.5 or 1/2. Tapos, ang unit niya is BTU BTU per feet squared. Yun yung natira. Tapos, meron kang hour. Hindi mo na na-cancel to eh. Okay, ito yung natira. So, anong gagawin mo dyan? Simplify mo pa. Q over A is equal to 0.65. Mamaya mo na i-multiply yung unit muna pansin natin. 1.8 times 55 over 0.5. Yung conversion factor. Ano bang pinakamadali para ma-change mo yung BTU? BTU per R degree. Degree? Hindi pala. R feet squared. Kailangan natin watt per meter squared. O, ayan. Meron tayong conversion factor na there are 1,055 joules per 1 BTU. Tapos, meron tayong 3,600 seconds in 1 hour. Tapos, ang pinupunto natin dito is meter squared. Okay? Meter squared. So, there are 3.28 feet in every meter. Kaya lang naka-square siya. So, i-square natin. Now, for the cancellation of units, we have feet squared, feet squared, feet squared, yung BTU, BTU, yung hour. Ano natira? Joule per second. I bet yung joule per second is watts per, ito, naka-meter squared dapat to. At is-square natin. Ayan, meter squared. Per meter squared. Now, we arrived with the required unit. So, we can now solve for Q over A. So, Q over A is equal to 0.65 times 1.8 times 55 times 1.055, hindi, 1055 pala yan, times 3.28 squared divided by 0.5 times 36. The answer is 405, very basic, 405.77 watt per meter squared. This is very basic problem. Okay? That is for problem number 2. How about problem number 3? A cold storage compartment is 4.5 meters long by 4 meters wide and 2.5 meter size. So, you have a room there. Ay, drawing natin yung room. Okay. Ito yung bahay. Wala tayong bintana. Okay. Yan daw yung room. So, this is 2.5 meters. Tapos, 4.5 meters long. Tapos, wide, 4 meters. Oh, basic. Now, this is the room. So, the four walls, hindi walls to walls, ceiling and floor are covered to a thickness of. So, meron daw thickness yung wall mo kung ito yung walling, a piece of walling, that is 150 millimeters. With insulating material which has a coefficient of thermal conductivity of 5.8 times 10 to the negative 2 watt per meter degree Kelvin. So, yun yung thermal conductivity K. 5.8 times 10 to the negative 2 watt per meter degree Kelvin. Calculate the quantity of heat in kilojoule leaking through the insulation per hour when the outside and inside phase temperatures of the material is 15 and negative 3 degrees Celsius. So, dito yung hot side, 15. Inside is negative 3 degrees Celsius. Okay, let us solve. Diba? Going back, conduction through walls, that is Q is equal to catex. Delta. Ayan. Now, yung Q is equal to K, given na yun. That is 5.8 times 10 to the negative 2 watt per meter degree Kelvin. Tapos yung area, surface area ang pinag-uusapan natin dito. Up. Tapos yung change in temperature from hot side to the cold side. That is 15 minus 3 degree Kelvin over yung X which is 150 millimeter. Okay. Ngayon, tignan nyo yung surface area of a rectangular solid. Ano yung surface area niya? Now, the surface area niya is equal to length times width plus length times height plus width times height. Multiply to 2. Yan yung kanyang surface area. Go back to your solid mensuration. Maalala nyo ito. Okay? Now, yun na yung dilemma natin. Okay? So, Q will be equal to, natapos na, okay? 5.8 times 10 to the negative 2 watt per meter degree Kelvin. Yung surface area is 2 times 4 times 4.5 plus 4 times 2.5 plus 2.5 times 4.5. And that is meter squared. Multiplied to ito, maiging 18 degree Kelvin. And then divide by 150 millimeter. Kaya lang kailangan maging meter. O di 150 divide by 1,000 para maging meter. Diretso na yon. So, we cancel all the same units. That is meter, meter squared, Kelvin, and Kelvin. So, ang natira is watts na lang. Okay, let us solve. That is 5.8 times 10 to the negative 2 times 2 times 4 times 4.5 plus 4 times 2.5 plus 2.5 times 4.5. times 18 divide by 0.15. The answer is 546. Okay, 546. So, Q is equal to 546.36 watts. Pero anong required natin dyan? In kilojoule. Ayan o. In kilojoule through the insolation per hour. Per hour. Okay? So, i-multiply pa natin to ng, kasi ito, joule per second to eh. Okay? There are 1,000 joule per 1 kilojoule. Times, ito, joule per second, di ba? There are 3,600 seconds per 1 hour. So, maka-cancel natin yung units dito ng joule per second. Palitan ko na ito ng joule per second, yung watts. Joule per second. Cancel the same units, the joule, yung seconds. Ang natira is kilojoule per hour. That is the required unit. So, you multiply it with 3.6 na lang. Kasi 3,600 divided by 1,000 is 3.6. The answer will be 1966. 1966.896 kilojoule per hour. That is problem number 3. Very basic problem. Okay? Very basic. So, let us take a break. And after this, we'll continue with problems number 4 and 5.